Okay, yeah, thank you to give me the chance here to make a small presentation about lift systems in high-rise buildings. And I would like to consider one side handling capacity and energy efficiency. So I'm looking more to lift groups, not to the single elevator like it is done, let's say, in the VDI. Also, we see more what's happening about using the right system at the right place, considering, let's say, space saving for having more usable space in the building, but also the energy saving. Now, first I would like to show some references where we already did such plannings with using, let's say, the right system at the right place. I go more into details later. These are worldwide, some of the references, not all. Most of these projects are still under construction, so we hope it will work as we planned it. Okay, I think coming back to some basics, this is the usual challenge of each lift consultant to say, okay, I want on one side, my customer want to have the highest building efficiency, so we have to get a very big usable area, even if it is a tower. On the other hand, I would like to have a highest traffic performance, a good handling capacity, and a good quality of service. So the conflict we get here, on this side, we need as many as possible elevators, and on the other side, these people they like to have as less as possible elevators because of the volume the lift shafts are taking of the building. We see here, for example, a low-rise building. There is a shaft maybe with 6 lifts inside. You go tall, then you get a low-rise, the high-rise group, or low, mid, and high-rise. And this takes a lot of footprint of the building, so the space around will be reduced very much. Another chance is to stack shafts. So you have a low-rise, mid-rise, and you get maybe a shuttle here. You have a transfer zone and you stack the shafts above them. Also this is a very common method to reduce numbers of shafts through the complete building. The shuttle has a very high handling capacity, so probably you would have maybe 10 shafts more through the complete building, and maybe you can manage this with 6 shafts. But okay, you need a transfer zone and people have to change the lifts on top of the building. This has nothing to do with the lift system itself. It can be done with double deckers, can be done with 2 independent cars in a shaft or single decks. It's a very common arrangement. Another possibility is using a more efficient controller system like the destination control technology. Destination control, I think everybody knows here in this room. So you enter your call before you enter the lift. The lift controller is able to group the people together, and so we reduce the numbers of stops, and therefore we very often get a better handling capacity. Concerning energy consumption, I would like to have a look to traffic flow in an office building. I took the profile from Lisa. We have the morning peak, where we need a lot of demand. Here we need also most of the cars. Then there is the morning interfloor traffic, a very low demand. The lunchtime peak, also high demand. And again a low demand during the afternoon traffic. So here we need all the cars, but what is happening here? So if you go for a destination control, and the destination control does not have any, let's say, learning function, and it's really very strict, designed for the shortest time to destination, then you waste energy probably in this area. A very simple example, maybe Ludwig and myself, we are standing in the lobby in the afternoon. A lot of cars are available because there is less traffic demand. You want to go to floor number 11, I want to go to floor number 10, and both of us get our own car, because it's the shortest time to destination for both of us. But this is energy wasting. So I would say, why should it not be okay for me to take a stop with Ludwig, and then I go ahead, so I only move 1 car instead of 2. This means controllers have a very big influence, group controllers, dispatcher, to the energy consumption in a building. Another chance to reduce the numbers of shafts in a building is simply the idea of why just installing one car within a shaft. In this big volume, there is probably space for 2 cars. So we know since a very long time the double-decker, usually mainly used as with 2 fixed cars. There are also flex double-decks where we can adjust some floor-to-floor distances, or we use a system with 2 independent cars. If you compare this, you already see it's a very big car, and I mentioned it in my paper. The empty car weight of maybe a double-deck of 1600 kg 2 times is maybe around 10 to 11 tons, depends on the outfit. This means your counterweight is maybe 12 tons. You need some ropes for it. Immediately you're in the area, you have to accelerate and decelerate 25 tons or more. This lift system, 2 independent cars, normal weights as a single deck, normal small machines, has some other advantages and disadvantages. I go to this later. Let's go first to the double-decker arrangement. So, as mentioned before, you could also make a shaft arrangement with all the double decks, with a low-rise group, a shuttle here, a transfer zone there, and maybe a local double deck also here. So the double deck has an advantage in the up peak. So here is maybe a single deck group and a double deck shuttle and a double deck local. So the double deck serves always 2 floors at the same time. This means it also reduces the number of stops, and you have an improved handling capacity, and you transport a double number of people within the same trip. And for sure this allows to reduce the numbers of shafts compared to single deck systems. We say, okay, group arrangement of top of each other. This means because we stack the cars and we have to have a different traffic flow through the building. I would say I prefer it as a shuttle because of the high lift masses which to have to decelerate and accelerate. Concerning energy consumption, it has a high efficiency during up peak when the car stops at 2 adjacent floors at the same time. Some disadvantages: less flexibility due to the connected cars. Equal floor distance is required if you don't have this flex double deck system. The heavy masses, even when there is light traffic, you move always 2 cars, maybe you only need 1. And there is some passenger irritation, mainly when it starts not only having a poor up peak traffic. As soon as you have some interfloor traffic, then we get the irritation, or probably we only use 1 car for the floor-to-floor trip. So, or somebody is waiting in the other car because this deck is loading or unloading. This is also, I see, a big disadvantage of this system. Coming as an example, what's happening, I think Len mentioned this morning, sometimes you really have a lot of interfloor in the building, interfloor traffic, and maybe a worst case situation could be you have a lot because of a single tenant building, or you have a lot because maybe worst case each of these companies rent 3 floors, and you have a lot of floor-to-floor trips from odd to even. You only can use 1 car. Worst case means you lose 50% of the cars when you use a double deck. The performance of double decks during interflow is really inefficient because the odd and even structure cannot be used anymore. In worst case, 50% of the cars you lose. It was never a problem, the interfloor traffic, for the single deck configuration. But what we find now in the planning is that double car systems, I say, doesn't matter if there's 2 independent cars in a shaft or double decks in a shaft, we get a double of floors per lift group. This means you probably have 30 floors within 1 lift group. Usually you plan single deck groups with 16 to 18 floors only in a group. Now you have the doubled one, and double deck later we only have probably 1 car to use for the interflow traffic. Also looking to some energy consumption. like before when I said, okay, a DSC control can waste energy, but also the double deck, because in the off-peak time, morning interflow, afternoon interflow, low demand, you move always 2 cars, even if you probably need only 1. So you accelerate, decelerate always these maybe 25 tons. What's really important in the planning stage, and therefore I like very much what was yesterday's discussion in the lift group. Let's really work with real traffic demands. We should consider always real traffic, to have peak traffic, to have at the same time probably some interflow traffic and down peak traffic, because only this can let you really verify which is if the system really works. We found very often in requests from some customers, yeah, please go for a double deck configuration, make 100% uppeak. Yeah, for sure, it will show a nice result. 100% uppeak is ideal for the double deck. It shows always 2 floors at the same time. You don't have the interflow component in it. But to verify it realistically, we should work with mixed traffic like we find in the real world. Yeah, then there is the idea of installing 2 independent cars within a lift shaft, and it is not related to odd and even floors, surfing. More or less, when we plan buildings, we bring low and high-rise groups together, and we say, okay, now the upper level, the upper lobby is the entrance for the high-rise lift, which is the upper car within the same shaft, and the lower entrance, and the lower lobby is it for the low-rise. I just did a small animation for a project we had in Paris, where we have a lot of independent cars running within the same shaft. Also here we can save the same number of shafts, like in a double deck system, maybe up to 50%, I would say 30% is always possible, up to 50, depends always on the entrance situation, how we can get this configuration. But we are flexible, and also the machines, everything is not so heavy, and due to the smaller masses, there is a lot of energy saving. Now this is a building here in London, where you can see all these independent cars running. Yeah. What I prefer in high-rise buildings is using each system at the right place, which means I see good advantages using the double deck as a shuttle, because here we don't have the interflow traffic, and it runs just from the lower lobby to the upper lobby, and using the system with 2 independent cars in the local group. So the transfer of the passengers can be always from the upper double deck to the upper car here, or from the lower double deck here, and you can get a really nice and very slender solution for the building with using the right system in place. Furthermore, the double deck is only used, let's say, in the long distance trips. Yeah, let's take the truck for the long distance. So you do also during the, let's say, low traffic demand times, less trips with the heavy system, which also saves energy, because most of the interflow trips you sure have in the local groups. Yeah. Here are some shaft arrangements with the 2 independent cars in one shaft. You probably have a low-rise group and a high-rise group. You can see that we have here upper car speed, lower car speed is different, which is not possible in a double deck. This means already due to this possibility, the lower car mainly serves interflow or in the lower area, so you have always shorter distance trips. We have less energy in the system. System energy or the power is always related to the capacity and speed. I prefer always a little bit shorter groups, not this long one. I think here working with sky lobbies concerning also energy efficiency is very good, because you can use here also the loader speed arrangement, and you have shorter ropes and everything which you move during the day during the interflow traffic, and saves energy. Now, this is a just an arrangement we did for a hotel. We had single deck shuttles to a lobby here. It was planned like this, so you had a shaft pit here, machine room there, a group downwards and the group in up direction. And with the system with 2 independent cars, we could bring this in one line, which was a very good arrangement for the structural engineer, for the construction side. Both cars, double deck or the independent systems, preferable work with a, let's say, double lobby, should be connected via escalator to keep the traffic flow. Important is the indication that people have the orientation in the building. Here, for example, for the independent car system, we say, okay, go to the upper cars, which is probably just indicated as high-rise lifts. If you would have the indication for double deck, you would say, even floors, please go to the upper lobby, or floors, please enter via the lower lobby. Yeah. Here also, if you look to a building, we want to have here the independent car system entrance level distance. We have to consider here a safety distance, which is maybe 5 meters or 6 meters, but the rest of the building can be completely independent floor heights. If you have a fixed double deck, this will drive your building design. Maybe all the floor distances are the same. If the lobby, which the architects, they like very much a bigger lobby because it's a nice room when you enter the building and not so tight. If this is maybe also 5 meters, and we go for a flexible double deck, and now this is what I indicate to the simulation program. The flexible double deck, if we serve directly from the main lobby the next floors, and it has to adjust maybe 1 meter floor to floor distance, there is not enough time during the travel time to reach the right distance. This means you stand in the floor and you still have some leveling delay until both floors fit to the floor to floor, both cars fit to the floor distance. I think this is not in the simulation program which we use. Maybe should be considered in future, because the leveling delays due to adjusting the cars will not be considered at the moment. Yeah, same building, let's say. There are a lot of companies, or maybe it's a single tenant, doesn't matter. But here, this system do not have any problems with interfloor traffic because it runs independent, so maybe each of these tenants can have his 1 or 2 cars during the day when there is interfloor traffic time, and you do not lose more or less 50% of the cars due to the odd and even configuration. Also, when you see, you always have short distances to the next floor, so there is not a double car here which has to make a long distance for an interfloor or download trip, because cars can be distributed so that you have always short distance to the next call. Energy consumption. I compared 2 systems, double deck and the 2 independent car system. A low-rise group is 4 meters per second double deck, 4 and 2.5 meters per second for the independent car. And both systems, if we would consider just this as a single car and calculate, then we probably could deliver as VDI rating of category A, energy efficiency class. But this goes lost here, because the double deck would use here much more energy due to the high moved masses, mainly in the off-peak times. The independent car system saves additional energy. So the VDI cannot be used, it's not there for lift groups, what's happening in the building. Here, a high-rise group, you would say probably 8 meters per second for sure. This double deck needs more energy than a 7 meters per second independent car system. But it was simply, we compare always same handling capacity and quality of service. And in this case, it was necessary to run the double deck with 8 meters per second to come to the same performance as the independent car system. And then we compare the energy consumption. This is what I'm saying here. Double deck wastes energy during low demand periods, most of the time of the day. These are all the green areas where it moves too much cars. When you only need 1, you move always 2. This is the advantage using the system in local groups. Yeah, energy efficiency, but here I speak about the power, the loads, the electrical loads in the building. You can also see the low-rise group. We have peak loads for the independent car system up to, let's say, here 300 kilowatts, depends always. Here you see different car loadings, travel directions, double deckers, more than a double. These are the electrical loads, the electrical cables, the transformers, maybe the generator size you have to prepare the building for. If you go to the high-rise, you see it much more. Sure, here we have more rope masses. We have the 7 meter per second independent car system. We have here maybe a load up to 800 kilowatts. Double deck goes up to 2 megawatt, 1.5 to 2 megawatt. And this in the 400 volt area. Here my conclusion. Preparing energy efficient vertical transportation system starts with the right planning. Usage of the building will be the basic for planning the right infrastructure of the building, which will define the number of required lifts. The right system for the corresponding usage is important to reach the highest efficiency of usable area with minimized building volume. No overdimensioning. This means finding the right speed, car sizes. Here in red, simulation with real traffic pattern, incoming, outgoing, interflow traffic allows the correct verification for planning the right system at the right place in the building. Ideal traffic pattern, 100% RP, considering no interflow or just working with interval calculation can lead to wrong conclusions. The system itself works with the latest technology, highest efficiencies of machines and drives. This is the VDI or ISO rating which Ingo presented. Energy recovery should be a must. Generated energy will be given back to the grid. Furthermore, we have less heat in the machine room. It's a must for high-speed lifts. Standby functions to reduce energy consumption. When elevator will not be used, switch off light, switch off drive. In case of destination control in the elevator group, the controller should be intelligent, provide energy regulating functions, not moving too much cars, let's say, in off-peak times. The number of moved cars should be minimized, and not used cars should be switched into standby mode. Thank you very much. Questions?
I'm going to try and sneak two questions, Jörg, if I may. The first one I think is an observation and then a question, but on one of your planning diagrams there you had that option where you had a shuttle to a high sky lobby and then up and down. And it strikes me that in some ways that is a reverse journey. And I think from Gina's book she quotes a UOB bank in Singapore that I think was planned as a shuttle up and then down. I'm just interested to know whether you have experience of commissioning a shuttle up and down system in any buildings around the world.
No, we did not realize this yet, but I would say from the psychological point of view, it's not good. Because if you want to go up to my office, it's not good to go up and down again. It's just from how the people feel to make such a journey through the building.
And my other quick question, if I may, Stefan, was you also mentioned the significance of the mass of rope in super high rise. And we've recently seen, in my opinion, quite a significant innovation in the industry. And I'm just interested in your thoughts on that, as to whether you think that will be followed by other manufacturers because of its significance.
Yes, I think so, because it's an important point when we speak about really these mega tall buildings where we have shafts with maybe 500 meter. We speak about 20 tons ropes, and I think the ultra rope from Kone is maybe only 10 or 20% of it, and I don't know exactly. This helps a lot saving the energy, for sure. The question is just about some long-term effect with this rope. It's one point, and I think it's probably the effect is not so high when we speak about buildings, let's say up to 200 meters with the lower power. I would say it's still reasonable to work with steel ropes.
Other questions?
Okay.
Just very quickly, two questions. I think the first one is there a rule of thumb for the mass of a double-decker, the car to two independent cars in terms of just mass, assuming obviously the same deck capacities?
Yeah, let's say one independent car, I would say, with 1600 kg and high speed is maybe also weigh up to 4 tons, which means we move 2 times 4 tons independently, not always also with the set. You have a different diversity in electrical loads, yeah. Probably it starts not always following it at the same time. In the double deck, the load 1600 kg depends also on the speed, let's say 7 meters per second. We have around 11 tons.
So you say
very massive car sling. Yeah.
It depends on the speed as well. It's a function of speed.
No, not only. I just thought we do not produce, let's say, the independent system more than 7 meters per second. Even if we could go according to with 8, it's after 7 meters, let's say 8 meters per second, we work with aerodynamic measures in the car, and then you have additional weight on a double deck.
The other question is the saving in energy. A big amount of it is due to mass, but is there also some of it caused by fewer stops? Could you say that the total number of stops is different?
I did not look really into this. In the past, I thought destination control also make a fewer stops, and maybe people think it will save energy, but it's not, because you do more high speeds.
So it's probably mainly due to the mass, the higher mass.
Okay, the less stops, okay, less acceleration then will help to save energy, yes.
Two quick questions from myself here. One, I noticed on your loading of the double-deckers or twin, it doesn't matter which one, you only showed an escalator. Please always remember to include a lift in that position. Disabled, very strong lobby group, and they're pushing very hard that all applications of that must have a means for them to get to that higher level.
Yeah.
And obviously that should have a bearing on your energy calculations, because those machines should be borne in mind with that energy consumption of the building.
I'm not sure if this is really necessary. Yes, in some applications, yes, but we could work with the same system if we give them a giveaway landing. Let's say you only need to come to the upper lobby when you go to the highest floor in the building.
Sure, but you've got to do that.
All other lower cars can reach, let's say, except of the last 2 floors, it can be reached everything by the lower car, and you can give...
I realise that, but the lobby groups say accessibility to all floors and all functions. If there's a restaurant on the top floor, you've got to have it.
Yeah.
And the other point is, I remember, we're going back a few years now, unfortunately a little bit too longer in the tooth, but Schindler brought out a group called the Mobile, which was, the main function of that was rope-less systems.
Mm-hmm.
Now this we're talking at least 20, 25 years ago. Have you looked at any further development on that? Because in terms of accessibility for mega high-rise buildings, also for egress of buildings where one system might get taken out of service in a disaster scenario, that is a very important function. Is that something you've considered?
You mean linear motor technology?
Yeah.
No ropes.
Okay, we have an appointment to get our picture taken. Gina had one brief comment she wanted to make before we go.
Yeah, I just thought, I'm not actually making the comment to you particularly, just a comment on the whole session, that people here might like to know what progress has been made with the ISO standards, and also in the UK we're concerned about the BREEAM credit system for classification in buildings. With the ISO standard, which has got this very complicated number 25745, you can remember it by adding the 2 to the 5 to get 7 and the 4 to the 5 to get 9, so you remember 79, then you can get 25745.
Keep it brief, Gina.
25745
Everyone's waiting for lunch.
Published in 2012 and includes the measurement system. The two other standards of interest is 25745-2, which is classification for lifts, and -3, which is escalators and moving walks. They're at the final draft international standard stage and have come out for voting at all the member bodies across the world. Hopefully they will be accepted, so those two will be out soon. In the -2, and in the dash 3 there are calculation methods for calculating the energy consumption on a daily or yearly basis. And that's necessary if you're going to look at your green ratings within any UK building which is using green, because there's two questions to get credits. The first credit is prove that you picked the most energy efficient system, and the second one is working out the technical aspects. In the first case, you need to do your calculation of energy consumption to prove it, and so those calculation methods are now available, or will be available, in the two documents, dash 2 and dash 3.
Okay. But it's always for the single lift and not for a lift group.
Sorry, we need to wrap up the
Please
session.
run.
Yeah.
Photographer's waiting.
So this is the point at which we're going to have the group photograph, and I'm going to be extremely bossy just for this few minutes, just because it's in everyone's benefit that we all get out really quickly, have the photograph taken, and then come back for lunch. So if you'd like to keep your jackets on, please, and if you follow Elizabeth, and if there's anyone left in the room after about 2 minutes, I'll be on them to get them out.
With who?
Something at the
Oh, finally. I think I heard that he left.
You coming for the photo? Yeah, come on. Come on. You're here.
Jackets on.
At least I know I was here.
Jackets on.
You have to
You have to stand at the back then. You're not properly dressed.
Improperly dressed. Wouldn't be the first time.
said, no, I'm not, mate, wait twice.
To convince you very much. Have to go to my computer.